I'm going to methodically show you how to determine the protonation state of an amino acid at, in this case, pH 7. So the general formula for an amino acid is that there is a central alpha carbon, which has a hydrogen attached to it, and an amino group, as well as a carboxyl group, and then there is an R group. The pKa of that amino group is 9, and the pKa of the carboxylic acid is 2. These are just sort of general numbers. If the pH is below a pKa, then that species is going to be protonated. So if we look at the amino group here, pKa is 9, and our pH is 7. So it's going to be in the protonated form. And notice I have 4 bonds and the positive charge on the nitrogen. So that's the protonated state. For the carboxylate, the pKa is 2, the pH is 7. And when the pH is greater than the pKa, and that's the case for here, then you'll have the deprotonated form. So for any amino acid, because I've said that we can just count the alpha amino group as having a pKa of 9 approximately, and the alpha carboxylate is always having a pKa of 2, then they will always be in their charged states plus and minus. So then we really just have to look at the R group. Now for aspartic acid, the full amino acid structure looks like this. Right, so I've already said that I'm going to have the amino group in the positively charged state, and the carboxylic acid is going to be in the carboxylate form, and then the R group for aspartic acid has a beta carbon and then a gamma carbon. The pKa for this is 4. So our choice is to have it either in the protonated state or in the deprotonated state. And because the pKa is 4, we know that when the pH is from 0 to 4, this is the form that will be in major concentration, and from 4 up to 14, this is the form that will predominate. So at pH 7, aspartic acid is going to have 2 negative charges and 1 positive charge, and the net charge will be -2 + 1 or -1.